Is all about being able to look at a quadratic equation in one of three different forms, pull out the information that you know about it on the graph, and convert between the three forms when you're asked to. When I look at an equation, it's quadratic equation in standard form, which is y equals ax squared plus bx plus c, the only thing that I can pull out without manipulating it and doing anything more with it, at a glance, I can tell that the y-intercept is at y equals positive 7. Because if I were to substitute 0 in for x, this would become 0, this is 0, and then y equals 7. I could, if it was factorable, factor it. I could do the quadratic formula. I could do some other things to find more information. But without doing any major manipulations, that's all I can tell from this form. Now, yes, I also know that it opens down and it has a vertical stretch with a factor of 3. That's not what we're looking for as much in this part of the unit. So, this is called vertex form because immediately at a glance, think about your transformations. I can tell that this was translated right 4 and up 12, which means my vertex is the point positive 4, positive 12. The y-intercept, I don't know. I would have to convert this to standard form to find the y-intercept. Do not get pulled into the y-intercept being 12. If I substituted 0 for x here, think about it, 0 for x, even without doing all the calculation, I know that y is not going to equal 12 because this whole part will not drop out. In this case, with factored form, it's also called intercept form. They're used interchangeably, so you need to know both of them. I can tell, based on what we did in the previous unit, that the x-intercepts are at x equals positive 6 and x equals negative 4/3. Again, without doing work, I can't tell the y-intercept, I can't tell the vertex. The y-intercept would be fairly quick to find, but I don't need to do that. Now, if I'm given an equation in standard form and they ask me to write it in vertex form, I need to do the completing the square that we've done. The problem is this, y does not equal 0 anymore. So I'm not just going to subtract 7 to get it to the other side of the equation. What I'm going to do is I want to make sure that I group my x squared and my x terms together. If the leading coefficient of the x squared is at 1, I've got to factor that out. I can't just divide by that anymore. In this case, the leading coefficient is 1. So I have x squared plus 2x, and then I need to complete the square. Well, remember, take the middle term, the coefficient of the x, divide it by 2 and square it. So 2 divided by 2 is 1, squared is 1, and then plus 7. Another thing that's different, though, is I'm not going to add 1 to the 7. Because the 7's still on this same side of the equation, I've now changed the value of this right side of the equation by 1. I've added 1 to this side of the equation, so to maintain the balance, I have to subtract 1 out here. So y equals x plus 1 squared. The positive 1, the plus 1 comes from the 2 divided by 2, and then this becomes plus 6. So from the original equation, I could look at this and I immediately knew the y-intercept, and you need to identify what you're finding. The y-intercept is at y equals 7, or the ordered pair 0, 7. Do not just put 7. And you actually have to identify that you're finding the y-intercept. And now that I've converted it to vertex form, I also know that the vertex of this equation is at negative 1, positive 6. Now, I don't know the x-intercepts, which are also called the zeros, the solutions, or the roots. I do know this just from the original form and the form I changed it into. I'm going to, again, group the x squared and x terms, but I need to factor 2 out. So 2 times x squared minus 20x plus something, and bring my plus 191 out at the end. Well, negative 20 divided by 2 is negative 10, which means I can also go down here and immediately start y equals 2 times x minus 10 squared. When I square negative 10, I get positive 100. I'm not just going to subtract 100 out here. Think about what this is. This is really 2 times 100. So I just really added 200 to that side of the equation. So I'm going to have to subtract 200 to maintain the balance. So minus 9, and I take my positive 191 and subtract 200 from it. Think about how you've changed the value of that side of the equation and adjust it out at the end. I know from the original equation that the y-intercept is at either the point 0, 191, or y equals 191 is also acceptable. And because I've changed it to vertex form, I know that the vertex is at positive 10, negative 9. Again, I don't know the x-intercepts because we didn't put it into factored form. Here, group the x squared and x terms, but I need to take that 1/4 out. So 1/4, and when I factor that out, what I have left is x squared minus 6x, and then plus something. Bring my 41/4 out to the end, and I know I'm going to have to subtract something in a minute. Oops, let me undo that. Subtract something in a minute. Negative 6 divided by 2 is negative 3, so this is going to become y equals 1/4 times x minus 3 quantity squared. Negative 3 squared is positive 9, but what I've really done is I've changed and I've added 1/4 times 9 to this side of the equation. So I need to subtract that 9/4 from the end. And then 41/4, positive 41/4 minus 9/4 is a positive 32/4, which is positive 8. So y equals 1/4 times x minus 3, quantity squared, plus 8. From the original equation, I know the y-intercept is on the y-axis at y equals 41/4. And now that it's in vertex form, I can tell that the vertex is the point positive 3, positive 8. The other examples in the notes will be in the part 2 video.